In this video, we're going to use unit analysis to do some problem solving. I've got 7 examples for you, and I'm going to try to go through this step by step. So the first example is an airliner travels 63 miles in 9 minutes. What is its speed in miles per hour? Remember, per was one of our key words, and that means division. So we want to change miles and minutes into miles per hour. So we're going to start off with 63 miles per 9 minutes. Okay, and now we want to change it to miles per hour. So I want to get rid of the minutes. And since minutes is in the denominator, I want to put minutes in the numerator. And I want to change it to hours. So I want to have hours down here. And I know that there are 60 minutes in 1 hour. So now I have my conversion factor set up. Here's my conversion factor. I can cross off my minutes. So in my calculator, I am going to put 63 over 9 in parentheses times 60 over 1. And when I get my answer, I'm going to get 420. And since I'm left with miles on the top and hours on the bottom, this is what's left here. And remember, division means per, so I've got miles per hour. In the second example, it says a human heart beats about 70 times per minute. So every minute it beats 70 times. So that's one of our conversion factors. Okay. It says an average human being lives to the age of 80. How many times does the average heart beat in a lifetime? So we want to convert the age of 80 years and figure out how many times our heart beats. So we're going to start with 80 years. And we're going to find a way to convert that into how many beats that would be. We want to incorporate our conversion factor in there somehow, but that uses minutes. So I want to change years to minutes. I want to get rid of years. So I'm going to put years on the bottom since years is on the top. And I know that there are 365 days in a year. Then I know in one day, there's 24 hours. And then I know in 1 hour is 60 minutes. So what I just did was I got rid of the years, I got rid of the days, and I got rid of the hours, and I'm left with how many minutes? 80 years. And then if I multiply this all out, it would give me the units of how many minutes it would be when you live 80 years. So now we're going to take that minutes and we're going to add our last conversion factor in there. That it's 70 beats. I'm running out of room here. Sorry about that. Per minute. So then by doing that, now I'm getting rid of my minutes. And I'm left with this unit right here. So I'm going to take 80 over 1 in parentheses times 365 over 1 in parentheses times, and go through and do that string of multiplication problem on your calculator. Now when you multiply all of that out, you're going to get a really big number. You are going to get 2, 9, 4, 3, 3, 6, 0, 0, 0, 0 beats. Decide which of the two given prices is the better deal. You can either rent a storage locker for $32 for each square yard per month, or you can do $2 per square feet per week. So in order to be able to compare these to see which one is a better deal, we need to put them in terms of the same units. So what I'm going to do is I'm going to change, let's change the yards squared to feet squared. And let's change the weeks into a month. And then we'll have square feet and then per month. So let's start with this one here. I have 32 yards squared. And I want to change yards squared into feet squared. Remember, this is it. This is what it is per month. That's this first one here. And then this is what it is per week. We'll do the second one down here. So I know that 1 yard is equal to 3 feet. But because this is squared, I need to square this whole thing. That way I get $32 over yard squared. And then when I square that, 1 squared is 1, yard squared is yard squared, over, then 3 squared is 9, and feet squared is feet squared. So now on the calculator, I'm going to do 32 over 1 in parentheses times 1 over 9. And that's going to give me $3.56 per foot squared, and that is per month. We didn't change the time on that one. So now when we look at the second deal, we're going to start with $2 per feet squared. Now we want to keep it in feet squared. Notice here I got feet squared and per month. I already got feet squared here, so I want to change per week into per month. And there's 4 weeks in a month, so I'm just going to multiply this by 4. And that's going to give me $8 per feet squared, and that's per month. Whoops. So now that I have them in the same units, I have per feet squared and then per the same time frame. If I notice, this one definitely looks like the better deal. So when you're doing comparisons, you want to make sure that you change it into the same unit so that you can compare. Okay, example 4. 2 friends take a 3,000-mile cross-country trip together, but they drive their own cars. One friend, we'll call him, he's driving car A, has a 12-gallon gas tank and averages 40 miles per gallon. So let's label this car A. We have, it's a 12-gallon tank and gets 40 miles per means division per gallon. Well, car B, let's see, has a 20-gallon tank. And let's see, also says that that car gets 30 miles per gallon. And we also need to know that the price per gallon at this point is $3.90 per gallon. So in part A, it says, what is the cost of 1 full tank of gas for car A and for car B? Since 1 tank for car A is 12 gallons, I'm going to start with 12 gallons. And the cost per gallon is $3.90. Now I want to get rid of the gallons and be left and have just the dollar sign left. So I want to put gallons down here and $3.90 up here. Then I can cross off my gallons, and when I multiply 12 over 1 times 390 over 1, I'm going to get $46.80. For car B now, car B has a tank that holds 20 gallons. So when he goes to fill up, he's going to have more gallons, so that's going to adjust or change the price that he pays. So he has a 20-gallon tank. So that's what we're going to start off with. And it's $3.90 per gallon. I put the gallon downstairs so I can cross off the gallons. And when I multiply that out, his cost is $78 even. Okay, the next question says, how many tanks of gas does car A and car B each use? So we know that they're making a 3,000-mile trip. So I'm going to take, for car A, I'm going to take 3,000 miles. Okay, we know that car A uses 1 gallon of gas for every 40 miles. I'm going to put the miles downstairs since I want to get rid of the miles, and then I can cross those off. And every 40 miles, this car uses 1 gallon of gas. And then we also know that car A has a 12-gallon tank. So 1 tank is equal to 12 gallons for car A. So now I can cross off all the units I don't want. I don't want gallons. I don't want miles. I want to be left with how many tanks of gas this guy uses, car A. Okay, so I'm going to take 30 over 1 in parentheses times 1 over 40 in parentheses times 1 over 12 in parentheses. I'm going to put that in the calculator, and that's going to give me 6.25, and that's going to be tanks of gas. So a little over 6 tanks. Okay, now we're going to do the same thing for car B. It's a 3,000-mile trip. Now car B gets, let's see, 30 miles. For every gallon of gas. 1 tank for him is going to be 20 gallons. So when I multiply that all out, I take 3,000 over 1 times 1 over 30 times 1 over 20, and I'm going to get exactly 5 tanks of gas. How much do the drivers of car A and B pay for gas for the trip? Well, I need to figure out how many gallons they use. And then once I figure out how many each of them use in gallons, then I can multiply the number of gallons by $3.90. So we did that up here. If we had taken everything up to this step, that would have given us the number of gallons they used if I stop there. So I'm going to take 3,000 miles over 1. This is for car A. In car A, the driver gets 40 miles for every gallon. That will give me the gallons that they use. So I can cross off the miles, and look what I'm left with. I'm left with gallons. But now I know that it's $3.90 for every 1 gallon. So now I can cross off the gallons, And when I multiply that out, I'll get how much car A driver spends. So in my calculator, I'm going to put 3,000 over 1 in parentheses times 1 over 40 in parentheses times 390 over 1 in parentheses. And I am going to get $292.50. For B, we're going to do the same thing. We're going to start with 3,000 miles. Car B gets 30 miles for every gallon. And then I'm going to multiply by $390 over 1 gallon. So I can get rid of gallons and I can get rid of miles, and that will be left with the number of dollars. So when I take 3,000 miles times over 1 times, and then in parentheses 1 over 30 times, and then in parentheses 390 over 1 gallon, that's going to give me $390 even. So whoever's driving car B, it's going to be a little bit more expensive. Okay, well, in order to talk about example 5, we need to give a couple of definitions. First, we need to talk about energy. Now, energy is what makes matter move or heat up. And the units for energy is called joules. And 1 calorie is equal to, when you burn 1 calorie, that's equal to 4184 joules. Now we also have power. Power is the rate in which energy is used. Okay, and the unit for energy, the unit for power is the watt. And a watt is equivalent to 1 joule per second. Okay, so it says, assume that riding a bike burns 50 calories per mile. So this is one of our conversion factors. If you ride a speed of 15 miles per hour, what is your average power output in watts? So we're going to start with 15 miles per hour. Per means division, so I'm going to put hour down here. For every 15 miles, that's 1 hour. Okay, now we want to change this into watts. Notice our unit for watt involves seconds. So I don't want hours. I want to change the hours into seconds. So I'm going to put 1 hour on top because I want to get rid of the hours. And I'm going to say that that's equal to 60 minutes. And I'm going to say that 1 minute is 60 seconds. So by doing that, I've gotten rid of my hours and my minutes. And right now I have this in miles. This is what's left. Miles per seconds as of right now. I also know that for every mile, this was another one of our conversion factors. I want to get rid of miles and change it to calories. Okay, so that way I can then change it to joules per second. This is a big chain, big string of conversion factors. I want to get rid of the miles, and I can use this conversion factor right here. I'm going to write, for every mile, you burn 50 calories. Since I want to get rid of the miles up here, I'm going to put miles down here. For 1 mile, that's 50 calories. We also know that 1 calorie is 4184 joules. So since I want to get rid of calories, I'm going to put 1 calorie down here and put 4184 joules up here. Now what we've got, I can cross off the calories, I can cross off the miles, and what we're left with is seconds down here, because I haven't crossed that off, and I'm left with joules up here. So since seconds is downstairs and joules is upstairs, I can say joules per second, which is watts. That's what we're looking for. So this is just a big string of conversion factors that I have to multiply them all together. So in my calculator, I'm going to put in parentheses 15 over 1 times 1 over 60 times 1 over 60 times 50 over 1 times 4184 over 1. It's a big string of multiplications. And we're going to get, let's say if we round to 1 decimal place, we get 871.7 joules per second, which is equivalent to 871.7 watts, because that's how watts are defined. It's joules per second. Okay. In example 6, it says, suppose you have a clothes dryer that uses 4,000 watts of power and you run it for an average of 1 hour every day. If you pay the utility company 14 cents per kilowatt hour of electricity, what is the average daily cost to run your dryer? Okay, so our dryer is 4,000 watts. That's what we're going to start with. And the units we have here are kilowatt hours. Remember when we talked about in the previous video that a dash is another way of saying multiplication. So first of all, I want to change the watt to the kilowatt. 1,000 watts is equal to 1 kilowatt. Then since it's per hour, we're going to multiply by 1 hour. Because that means to multiply the little dash there. And then that's going to give us kilowatt hours. Okay, because we're going to cross off the watts and we're left with kilowatt hours. Okay, now it's 14 cents per kilowatt hour. So then I'm going to finish by multiplying by 14 cents per 1 kilowatt hour. Okay, so now I can get rid of the kilowatt hours. And now this is just a string of multiplication problems. It's just a string of conversion factors that we need to multiply. So I'm going to take 4,000 over 1 times 1 over 1,000 times 1 over 1 times 0.14 over 1. When I multiply that out, I'm going to get 56 cents. Now down here it says, how much would you save if you replace your dryer with the more efficient model that only uses 2,000 watts? So we're going to do the same exact thing that we just did above, but we're going to do it with 2,000 watts. I'm going to take 2,000 watts over 1. Then I'm going to multiply it by 1 kilowatt. That's equal to 1,000 watts. And since it's kilowatt hour, I have to multiply by hour because the dash means multiplication. And then it's 14 cents per 1 kilowatt hour. So now I can cross off my watts. I can cross off my kilowatt hours. And when I multiply all that out, I get 28 cents. Okay, so the difference between when you run a 4,000 watt dryer and a 2,000 watt dryer, if you do it for 1 hour every day, if you take the 56 cents and subtract the 28 cents, that's going to be a difference of 28 cents a day, because you run, on average, you run it 1 hour every day. Now, if you take that 28 cents and you multiply it by 365 days, you can see that when you multiply that, you get $102.20 you could save per year. Suppose a dose of 9,000 units of kilograms, and kilograms would be the body weight, of penicillin is prescribed every 6 hours for treatment. Every 6 hours means 4 times a day. For penicillin, 4,000 units is equivalent to 250 milligrams. Okay, express the dosage in milligrams per kilogram of body weight. So we're going to start with 9,000 units, and that's per kilogram for the body weight. And for every 250 milligrams, that's equivalent to, that's our unit conversion factor, it's equal to 400,000 units. So what we just did is we got rid of the units, and we're left with milligrams per, because it's downstairs and we're dividing, milligrams per kilograms of body weight, which is exactly what we wanted. So I have to just multiply this out on my calculator, and I'm going to put in on the calculator in parentheses 9,000 over 1 times, and then in parentheses 250 divided by 400,000, and we're going to get 5.625 milligrams per kilogram, and that's a body weight. So in part B, it says how many milligrams of penicillin would a 20 kilogram child take in 1 day? So 1 day means you're going to have 4 doses, because it's every 6 hours. So we're going to start off by multiplying by 4, because we're going to do 4 doses. And what we had above, what we figured out above is that it's 5.625 milligrams per kilogram of body weight. And the problem says that the child weighs 20 kilograms, so I'm going to multiply by 20 kilograms. So by doing that, I get rid of my kilograms, and it tells me how much total the child would take in the entire day. Now, if I just wanted it in 1 dose, I wouldn't multiply by 4. But we want to know how much total it's going to be for all 4 doses for the whole day. So I'm going to take 4 times 5.625 over 1 times 20 over 1. I'm going to multiply that out, and I'm going to get 450 milligrams for the whole day. This is for all 4 doses. That's why we multiplied it by 4. If we only wanted to know for 1 dose, we wouldn't have multiplied by 4. So those are some examples you can use while you're working on your homework to kind of follow along, to practice, and kind of use as a guide when you're practicing on your own.